Hello, today we'll discuss one more industry as a part of subject municipal and industrial wastewater engineering. Today we'll discuss pharmaceutical industry. Pharmaceutical industry produce varied types of products. They range from vitamins, synthetic drugs to antibiotics. The raw materials used includes both organic, inorganic compounds. Some of the pharmaceutical plants do not generate any type of liquid effluents, while some of other discharge little quantities of strong waste and other let out larger volumes. It is depending on type of pharmaceutical industry, type of antibiotics produced, etc. Due to this wide range of generalization cannot be drawn on effluent of a pharmaceutical industry since the product and effluent are entirely different from industry to industry. The most waste produced in the fermentation process is the spent beer liquor. Spent beer liquor is the fermented broth remaining after the recovery of antibiotics and other valuable byproducts. So broadly, we can classify pharmaceutical industry into five types depending on their waste and the characteristics of waste. First one, strong fermentation beer, the, small in the volume but having high BOD content, 4000 to 8000 milligram per liter of BOD. Inorganic solids may vary with the little BOD. Washing of floor and equipment, large percentage of total volume and BOD from 600 to 2500 ppm. Chemical waste, solution or solvents which extract a substantial BOD when diluted with other waste. And barometric condensers, wastewater, resulting from solids and volatile gases being mixed with condenser wastewater causing 60 to 120 ppm of BOD. So here it is broadly classified depending on the BOD concentration as well as inorganic solids and washing of flows and equipments. Antibiotic waste impart objectable odor to stream. The volume and composition vary from unit to unit. Approximately 1000 to 3000 liters of waste will be discharged per 100 kg of product manufactured. In general, they are either highly acidic or highly alkaline and possess high BOD and COD. Some of effluent contain toxic substance like cyanide. So here, depending on type of effluent coming, like highly acidic or alkaline, we can go for neutralization. We can go for neutralization and later equalization. In neutralization means it is acidic, you are going to add alkali, or alkali means you are going to add acid. In this way, we can able to control this. Effect of waste on receiving water, CO. If a crude waste from an antibiotic waste is discharged into the stream, it not only imparts an objectable odor to the stream, but also adversely affect the biological process in it. How we can able to treat antibiotic containing wastewater? As I mentioned earlier, we have to go for different types of processes where we can able to reduce effluent characters before it's going to discharge into water bodies, like equalization, neutralization, and clarification are the essential steps involved in the primary treatment of this waste. Anaerobic digestion and controlled aeration are proved to be effective in secondary treatment. Activated sludge and oxidation ditch are also employed in some of the pharmaceutical manufacturing units. The effluent from secondary treatment may be passed on to a sand filters to produce effluent of better quality. So in general, we can say type of effluent coming from the industry. We have to stick on to that characteristics so that we can able to remove. Too much acidic means you have to go for neutralization. Second, you can go for equalization. If you're having much of suspended solids, you have to go for clarification. If it's having more amount of BOD, we can go for another digestion with controlled aeration and activated sludge or oxidation ditch. So typical flow chart can be given by a combined factory effluent is coming. First one, you're going to go for equalization. Since this is the acidic, you're going to add lime, then clarigesture, where you can go for clarification. Once clarification is over, set level particles are taken to sand drying beds, where it will be dried and water will be percolated and organic materials can be disposed of. And the other one is we have to go for activated sludge process. This method used when BOD is very high. We are going to go for a return sludge. If efficiency has to be more, again the active return sludge has to be provided so that still the efficiency has to maintain to the effluent standard. Once activated sludge process is over, it go for settling tank where organic solids are going to settle, then effluent will be discharged. In this way, a typical flowchart of a pharmaceutical industry with equalization, activated sludge process, and sand drying beds are used to treat some of the combined antibiotics and other chemical waste. In this way, depending on the type of industry and other thing, we can going to decide the type of operation or process has to be involved here. Thank you.